So I want to preface this with it's very awkward to teach to a class of no students, but hopefully this will be beneficial for you guys to go along with your guided notes and what you do at the sub on Friday. You hopefully started with this warm-up with discussing these questions with your partners. You should have gotten, for the choosing 2 lucky students to come to the math camp, 32 choose 2 because the order of the students didn't matter. And then for the 32 students needing to choose 2 people to become president and vice president, the order does matter. When you pick your president, you're going to have 32 options, and when you pick your vice president, you're going to have 31 options. So that's one way to do it, or you can do 32P2, because you're picking 2 students out of the 32, and the order does matter in this case. The warm-up continued. I was hoping you would discuss with your partners how to, if you draw 2 cards from a standard deck of 52 cards, finding the number of ways of drawing these different options. So different options. So I will show you the way that I did it, and maybe you and your partner did it a different way. But for drawing 2 spades, so we know there are 13 spades in a deck of 52, so we've got 13 options. And the order of these spades doesn't matter, so I did choose, and then I only want to pick 2 of them. So I did 13 choose 2, which turns into 78 if you do it in your calculator. If we wanted to do a pair of kings, how many kings are in a deck? There are 4 kings in a deck, so we've got 4 options. Once again, the order doesn't matter, and you're choosing 2 of them, which would give you 6. For any pair, I got a little bit confused on any pair, but pairs in poker mean like 2 2s, 2 3s, so you're looking for like matches. So if you're wanting just any pair at all, you're first going to need to start by picking 1 card. Out of each of the different sets of cards, so like spades, hearts, diamonds, there are 13 different options within them, 1 through ace through king, or 2 through ace, however you want to see it. So you're going to start with picking one of those cards that you want to match. So you've got 13 options within a suit, and you're choosing one of those cards to make a pair with. Then, to figure out what other cards should pair with it, it's now got 4 different suits that there can be pairs made within. So we've got 4 suits, and we're going to be choosing 2 cards from those suits to make our pairs. So if you multiply those 2 groups together, we're going to end up with 78. Just kind of like the 2 spades problem. How about if we draw 5 cards from a standard deck of 52 cards? And so we've got a few different parts we've got to look at. So if we want 3 aces out of those 5 cards, then to figure out, we know there are 4 aces in a deck, but we only want to pick 3 of them. So we've got 4 aces, and we're choosing 3. Our order didn't matter. And then to figure out the other 2 non-aces, so whatever's left in the deck, you've got 52 cards, and you've already picked the 4 of them, so we've taken out 4 aces, so there's 48 cards left. So we've got 48, and we're choosing 2 non-aces, so we're choosing 2 more cards to fill out those 5 cards. So if you calculate that, you should end up with 4,512. For 4 of a kind, that's kind of a step up from that. So you got to start just like when we did the any pair. This time we want to find like 4, so it's like a pair of 4 or 4 of a kind. So you've got 13 cards to select out of every suit. So we first need to pick the 1 card that we want to match everything else to. So we had 13 cards, we picked 1 to match everything else to. Now there should be 4 of those cards. So we should have 4, choose 4 to find the cards that match to make our 4 of a kind. And then because we're doing 5 cards, we need to find what that leftover card would be. So if we subtract 4 from 52, we've got 48 cards left, and we want to choose 1 card out of those 48. Something to note, if you look at other notes, you might see this 13 choose 1 written just as a 13. So you could write this just as a 13 being multiplied by everything, or you could say 13 choose 1. So those are both options for that. So this equals 624. Another thing that appears on yours that I forgot to add on to this is for C, if we're looking for any pair, so not just 2 of a kind or 4 of a kind, so any pair at all. if we wanted to do any pair, we first need to start with choosing that one card out of a suit to look at. So we've got 13, and we're choosing one card. Then we need to find its pair out of the 4 different options you have amongst the suits for that one card. So you've got 4 of that card, say it's like 4 jacks, but you want to pick 2 of them because you're just wanting any pair. Then we need to find those 3 other cards left over that would fill out that 5-card hand. So we could subtract the 4 cards that we've already dealt with, that we already had as part of our options for our pair out. So we've got 48 cards left, and we're choosing 3 cards to fill out the rest of that 5-card hand. So you multiply these all together, you're going to get 1,349,088. Good. So that is the first section. So probability is the new introduction for today. So what we just did should have been some review. So what is the probability of? So without even using our fancy combinations, permutations, just thinking about this like you would have in maybe elementary school. So tossing 3 heads, or what's the probability of tossing 3 heads in a row with a fair coin? So if we just did the first coin, the probability of getting a heads is 1 out of 2. If we toss another coin, the probability is still 1 out of 2. And we toss another coin, the probability is still 1 out of 2. So if we multiply these through, we're going to get 1/8. For drawing a king from a standard deck of 52 cards, well, we know there are 4 kings in a deck, so we're going to have 4 divided by the 52 cards. And then that can be simplified to 1 out of 13. If we want to roll a 12 on a single, rolling a 12 on a single roll of 2 dice. So we know if you're rolling 2 dice, the only option for getting a 12 is if you roll 2 6s. So 6 plus 6 would give us that 12. Then if we, to figure out how many options that we have, if you've got 2 dice with 6 different sides, 6 times 6 is going to give you your total options. So there are 36 options, and only one way can give you a 12. So we've got a one way of giving us that 12, and we've got 36 different rolls that we could have with the dice. So that's our probability for rolling a 12 with 2 dice. So in general, if we're wanting to find the probability of an event, we write that with a P, and then in parentheses, you write whatever the event is we're finding the probability of. So this line represents a fraction. So on the top of your fraction, you're going to have the number of ways of getting the desired outcome. So how many different ways can you get what you're wanting to look for? Then you're dividing that by the total number of possible outcomes. So whenever you set something up, your total number of possible outcomes, it may stay the same for a lot of problems. In the card problems, your denominator will be the same for a lot of problems, and the numerator will be what is changing. So it states probability is a number between 0 and 1. It can be expressed as a fraction, a decimal, or a percent. So those are numbers between 0 and 1, so that makes sense. The probability vocabulary we'll look at more later, but there's a list of vocabulary for you. So, problem 1. You draw 2 cards from a standard deck of 52 cards. What is the probability of drawing? So our first option is 2 spades. So on the bottom, we want the number of total possible 2-card hands. So we know there are 52 cards in a deck. So we've got 52. And the order doesn't matter. And we're choosing 2 of those cards to make any set of pairs. To do spades specifically is what we're looking for on the top. So we know there are 13 spades in a deck. So we've got 13. And then we're choosing 2 of those spades in order to draw 2 spades. We're doing a pair in general, so not just 2 spades, just any pair. What you're looking for is the number of ways to draw a pair. And you're dividing that by the number of ways, oh, just kidding, the number of total possible two card hands, which is the exact same thing as the first one we dealt with. So the total number of two card hands is the same as it was above. So it's still, we have 52 cards in a deck, and we're choosing 2 of those cards. And then on the top, so the number of ways to draw a pair. We talked about this a little bit in the warm-up. So if we're wanting to pick a pair, we have to pick one card to start with, and there are 13 different cards in a suit. So we're going to have 13, and we're going to pick one card that we want to match another card to. And then out of that one card that we picked, there are 4 others like it. So we've got 4 cards, and we're choosing 2 cards out of those 4 cards, and that is our pair. So we should have maybe like 4 jacks, and we've picked 2 of them as our pair. For problem number 2. So we kind of just going over vocabulary on this slide. So you flip a fair coin 3 times. What is the probability that you get 2 heads and 1 tail? So a trial is each coin flip. Your experiment is all 3 coin flips, so all 3 trials. The event is flipping 2 heads and 1 tail. The outcome is the sequence of the results of the 3 trials. This outcome looks like a 3-letter word. So I know we use this word word a lot. I know this doesn't really make a word, but we're calling it a word. So it's kind of like quotes word, made of H's and T's. And then your sample space is probably the vocabulary word that I like the best. And that's a list of all the total possible outcomes of the experiment. So all of these different options that we could have for our problem that we're trying to figure out. So completing that problem, so we're trying to figure out if when we flip a fair coin 3 times, what is the probability that you get 2 heads and 1 tail? So you first want to figure out the denominator, because it's just nice. We don't have to figure it out first, but that's what we're going to do. So there are 3 different ways that I'm going to demonstrate that we could find it. So we want the number of possible outcomes for flipping a coin 3 times. So the first way we could do, if you wanted to take a while, is draw a tree. So when you flip the coin the first time, you're going to get 2 options, a head or a tail. This one will also have 2 options. This could also be a head or a tail, and this one could also be a head or a tail. So that's 2 flips. So we have 2 different rows. So this is row 1, row 2. And then our third row is going to also have 2 options for each of those rolls or flips. So we have a heads, a tails here, a heads, tails here, heads, tails, heads, tails. So we are trying to find the count. So it's count the number of terminating branches. So how many different options do we have? So 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 total options for our different options that we have with our different flips of the coin. Another way that we could have found this is making a list. So you could have listed out T, 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 H, T, H, T, going on and on and on, and counting all of your entries. If you do that, you will also get 8. Another way you can do this is the way that we've been talking about in class, where if you flip a coin, it's kind of like the yes/no toppings problems, where you could either say yes or no to a topping. Here, you're either going to get heads or tails, so it's like yes heads or no tails. Yes heads or no heads. So you're just taking 2 times 2 times 2, or 2 to the 3rd power, because you're flipping it 3 times, which would also give you 8. So that's our denominator, is that 8, because that's the total number of options. To find our numerator, we want to calculate, we could look at this a few different ways. So we could look at our tree diagram that was on the previous slide. So if we're looking for options that contain 2 heads and 1 tails. So I'm going to go back to the other slide. So 2 heads and 1 tail. So here's an option, 2 heads and 1 tail. Here's another option, 2 heads and 1 tail. Here's another option, 2 heads and 1 tail. I think that's our